What I'll do in this video is work the MCQ of the 2021 Exam 2 Semester 1 Methods paper, and then in a separate video I'll do the analysis section. So here we go. Question 1 is a linear function going through 7 and 3. So as x increases by 3, the y values go down by 7. So the gradient is -7 on 3, and the y-intercept is 7. So our function will be -7x on 3 plus 7. Nah. So obviously it's a transposed version of that, which is a bit tough for a first question, but what we'll do is we'll multiply all of this by 3. And then what we'll do is swing them over to the left-hand side. So I think the answer is E. Let's go 3y plus 7x, take 21 equals 0. Yeah, it's E. Okay, the polynomial that expressed as the product of 3 linear factors is equal to. So all you would do with this one is go action, transform and factor, and feed it the polynomial. Take away 12x squared plus 5x plus 6. So we're looking for a 2x plus 1, 2x take 3. Next, it's E. Alright. Flying. Okay, the midpoint of the interval PQ, where P has these and Q has these, is one of the following. So let's just use the midpoint formula, which is the average of the x values, average of the y values. So it's none of these, so it's obviously a different version of that. So what this could be expressed as is b take 2 all over 2, comma b take, let's do a common factor for this, so over 2 over 2, that is going to be b over 2 over 2. That could then be written as b on 2 take 1, b on 4. Yep, there it is there, b. Okay, the maximum value of h in the function 0 to infinity is, okay, so this is an inverted parabola, -1, 2, it goes like that, and the maximum value, because it's 0 to infinity, this part of the function is not relevant, it's only this part here. So if we do h of 0, that'll give us the maximum value, because that's what it will be. So h of 0 equals -1 squared plus 2. -1 plus 2 is 1. That's our highest value. The graph of the equation shown above is, so this is a truncus, and it's inverted, and it's gone up 2 units, and to the left, to the right rather, 1. So it's going to be 1 over x take 1 squared plus 2 inverted. I've assumed no dilation, and each one of them hasn't been dilated, so I can assume that in this case. So it's one of these. It is going to be 2 take away 1 on, yep, it's E. The gradient of a line that makes an angle of 150 degrees with the positive direction of the x-axis is, okay, so this is roughly 150, or that's 30 degrees there. So what we're looking for is the gradient, so it's going to be negative, so that's gone, so it's one of those. And the best way to do this is probably run m equals tan theta, using that formula there. So m equals tan of 150 Tan can be found by doing a shift and 3, 150. Let's make sure that we're in degrees. So it's negative root 3 on 3, negative 5, 0.577. There it is there. Okay, the equation of the graph shown above is, so what it is a standard cubic that's been inflected. So we're going to go, and so what I'm noticing here, I'm just having a quick look at the answers. This has got no dilation, this has. So I'm going to assume that there's some sort of a dilation here. So I'm going to go y equals a, x, so how far is it shifted? X take 1 cubed plus 2. And we're going to sub one of these points in. So I'm going to sub the y-intercept. So 4 equals a negative 1 cubed plus 2. 2 equals negative a equals negative 2. So my function will be y equals negative 2, x take 1 all cubed plus 2. This looks the goods. 2 take away, yeah, there's our winner. The coordinates of the turning point of the graph with the equation are, okay, so a lot of you will pick like 4, 5 as the answer to this, but it's not, okay, so what you want to do is get this down to what we call the single x, so y equals 2, comes out x take 2 squared plus 5, y equals 4, x take 2 squared plus 5. Okay, so this is a translation 2 to the right, 5 up, and a dilation factor 4 from the x-axis. So turning point is 2, 5. For f of x equals that, f of b, take away f of 2b is, right, so this is just a punch it out on the calculator type question. So I'm going to go shift 7 for define, f of x equals 3, take away x squared. Then all I'm going to do is f of, now you can use b or you can use z, doesn't really matter. F of z, take away, so shift 8 for f of, so this will be 2z. And there it is there, 3z squared plus z, that's C. Okay, which one of the following graphs represents a relation that is a function? Okay, so this is a relation, but it's not a function because it fails the vertical line test. This is a relation that is also a function. So that's our answer. This one here fails the test, and this one here is a linear, but it's not a function because the vertical line passes through infinite number of points there. So B is our answer. Right, so halfway there, 8.5 minutes gone, not bad. Okay, the set of values of k for which the graph of h has two x-intercepts is. Okay, so these ones here, what we need to do is we know that 2 x-intercepts happens when the discriminant is larger than 0. So what we've got to do is get the discriminant of this thing here. So a is equal to -1, b is equal to 2k, and c is equal to -3. Alright, so now we'll go b squared take 4ac greater than 0. B squared is 2k all squared, don't forget that, take away 4 times -1 times -3 greater than 0. So we've got 4k squared. This is going to be 3, 12, take away 12, greater than 0. Okay, now k squared greater than 12, k squared 3. Alright, so what we'll do is we're going to sketch this graph here. So this one here, what we'll do is go it goes down negative 12. So that's what the graph is going to look like. And what we want to know is when it's greater than 0. Okay, so remember, this is when k is equal to 0, k greater than 0, k less than 0. And this, remember, is the discriminant here. So what we're after is when it's greater than, that's these parts here. What's the x-intercepts going to be? Well, it's k squared greater than 3, k greater than... actually, this is tricky because I can't say greater than because it's not true. So I'm going to get rid of this. Okay, and what I'm going to do is actually solve for k squared less than 12 is equal to 0. I want to find out what these x-intercepts actually are. So it's 4k squared equals 12, k squared equals 3, k equals plus or minus 3. So that is negative root 3, that is root 3. So it's these parts here. So it's negative infinity to less than negative 3. So that is that one there. It's not inclusive there. Okay, so that meets the requirements. And then it should be root 3 to positive infinity here. So it's an E. The graph of a polynomial function is shown on the set of axes below. The number of stationary points on this graph is a stationary point. I think it's a stationary point. I think this is a stationary point of inflection, although it could be a point of inflection, so I'm not sure. Stationary point, stationary point, stationary point. So we could have 1, 2, 3, 4, 5. It could be 5. Or if that's a point of inflection, the answer could be 4 as well. So 4 isn't in here, so it must be 5. So this has to be a stationary point of inflection, not a point of inflection. The rule of a polynomial of degree 3 is this. P of 2 equals negative 14, then the value of k is. Right, the easiest way to do these problems is, let's go shift define. We'll go Z instead of the K. Okay, so what we'll do is run solve. So action, calculation, is it? Advanced solve. And f of 2 equals negative 14. And what we want to do is find the value of Z for which that occurs. So Z is equal to 4. K is equal to 4. Ooh, that's interesting. I'll type it in right. Ooh, plus 2x squared. 12. Okay. All right, crisis averted. So this is f of x. The graph of x is translated 1 unit upwards, then reflected in the y-axis and dilated by a factor of 5 from the x-axis. The graph of the image of the function is defined by. Okay, so a couple of ways to do this. We could do this via the mapping. We could do this via function. So what I'll do is I'll do it via mapping, which seems to be the preferred method of year 11s. Then I'll quickly bang it out via function. Okay, so we've got x comma y maps to. F is translated 1 unit upwards, so that's x comma y plus 1. Dilated by reflected in the y-axis, so reflections in y negate x. Dilated by a factor of 5 from the x-axis, so dilations from x change y. That's x dash and y dash. X dash equals negative x, y dash equals 5, y plus 1. Okay, what we want to do is solve for x and y. So x equals negative x dash, y dash on 5, take 1 equals y. So there's our original. So let's bang in y for f of x. So we've got y on 5, take 1, drop my dashes, equals root 5 negative x, goes on for x, take 1. So this is going to be y equals root negative 5x. Now what we'll do is we'll add 1, so it's y on 5, add 1, which chops out the 1, and then multiply by 5, y equals 5, root negative 5x. That one. And obviously we don't need to worry about the domain because that's the only correct answer. So that's the mapping method. Let's do it via function. So I'd go a shift define f of x equals and shift root 5x take 1. Oops. Okay, so what we'll do is translate 1 unit upwards, so that would be f of x plus 1. So there it is there. Reflected in the y-axis. Okay, so we reflect in the y-axis, we drop in negative x, so that would be that. And dilated by a factor of 5 from the x-axis means we'll do 5 times that. So 5 lots of that. Simp that down. Ooh, what's happened there? Ah, that's naughty. Brackets, Mr. Miller, brackets. Okay, so 5 lots of all of that stuff happening. So there it is there. So that's how I'd bang that out quickly on the calculator. When that is divided by this, the remainder is. Okay, so again, classic calculator problem equals x cubed plus 2x squared. Okay, and what we'll do is f of 2 on 3. That. Okay, the union is that, A is that. So these ones here, just smash these with a Carnot map. So it's going to be 1, this is A, not A, B, not B. There's a couple of these on the 3-4 methods exam last year. So we want probability of A, not A and B. So we want this one here. So A is 0.3, so that's that. 0.7. The union is equal to 0.85. Oh, A and B is 1. Okay, now that means that that is 0.2 to get to 0.3. How am I going to get that? So we've got the union. Yeah, there it is. So the union is going to be. So the union is these 3 things put together: A and B, A and not B, or A only, and B only. So all I'll do is from 0.85, I'll remove the intersection and A only, which is 0.3, and let's just stick to decimals. So that's going to be 0.55, which is actually what we're after in the first place. So that has to be the answer. A box contains 2 red marbles and 4 blue marbles. 3 marbles are selected without replacement. Find the probability that all 3 marbles are not the same color. Okay, so like basically we get red or blue, red or blue, red or blue. This event doesn't exist because there's only 2 red marbles, so that event can't happen. So what I'm going to do here, find the probability that all three marbles are not the same color. I'm going to find the probability that they are the same color. That means I want to find out the probability of blue, blue, blue. And then what I'm going to do is remove that from 1, and that will give us everything else in the tree diagram. So blue, blue, blue. Now, blue, probability of blue initially is 4 in 6. Is that right? Yep. Then another blue is 3 in 5, and the last blue is going to be 2 in 4. So I'm going to do 1 takeaway, 4 on 6, times three on 5 times last one, 2 on 4. 0.8, 4/5, I think. Yeah. Okay. On a bias coin, the probability of a head is P. Coin is tossed twice, at least one head. Okay, so these ones are hard. So either when you toss a coin, you get a head or a tail, and the probability of a head is P. That means tail is going to be 1 take P. Now, because a coin toss is independent, this is going to be P, this is going to be 1 take P. This is going to be P, 1 take P. And at least one head means head, 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 tail, tail, head. So this is basically going to be not tail, tail. So if I work out probability of tail, tail, and then remove it from 1, I'm going to get at least one head. Alright, so probability of tail, tail is going to be 1 take P times 1 take P. You guys can use Z there if you want. So there's that. 1 take away that. 1 take away shift. Answer is that. And what we'll do is we'll just try simp to see if we can get it in the right form. What do we got here? Negative P squared plus 2P. Is that one of them? Where is it? Oh, there it is there. Negative P squared plus 2P. Starting to doubt myself there, girls. Okay, the range of a linear function with a rule, blah, 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 is, the domain of f is. All right, so what this is the range. What we want is the domain. So what we've got is this function here, 1, so it goes like this. And what it does is 5 and negative 5 are the y values produced. So what we basically want to get is the x value there and there. That's going to give us the range. So the best way to do this is to ask f of x a question. Just go, hey, when are you negative 5? That's negative 6 equals negative 2x, x equals 3. So it's going to, is that right? X equals 3. Yeah, is going to give us negative 5. So that's that value there. So that's the upper. So all right, let's just get the what. This is hard, so I'm having to think a bit here, girls. This one here will go 5 equals negative 2x plus 1. 4 equals negative 2x, x equals negative 2. Okay, so it's going to be negative 2 to 3. Now, what this range means is this is included, this is excluded. So that's 2, that's 3. There's our answer. Okay, consider the function that. So 1 on x looks like that. That's a hyperbola. A and b are positive real numbers, and a is smaller than b. So this is a, this is b. Okay, this value is included. This value is excluded. Okay, we want to get the range. So if we bang b in, this one here is going to be 1 on b. This one here is going to be 1 on a. These are the y values here. So the lowest value is 1 over b. The highest value is 1 over a. This one here is not included. This one here is included. 1 over b, 1 over a. Alright, so there is the multiple choice. That took 26 minutes. That's a long time.